Okay, so with that, before we start some new stuff today on the hypothesis testing I was talking about, or inferential statistics. So 2 weeks ago, yes, we did start inferential statistics, but today and this week we're going to do a type of inferential statistics called hypothesis testing. Okay, but before we do that, any questions on anything so far, Marcella? Like, when do you say you had the question on the problem you worked on for an hour? Or
Well,
we can go over that or later. Or while she's perhaps any questions I want to go over the MyStat lab or concepts so far in the last 6 weeks?
questions I have all questions. Right now, I can't think of any.
Okay. All right. Okay, so if you ever think any questions, let me know. So in the meantime, we'll start hypothesis testing now. Okay, and I did post lots of stuff like a plan and everything that you can download and follow along today. So that's in activities and assessments, and then discussions. And then where have I been posting all the plans and stuff? Insights, very good there, Wendy. So we'll go to insights from faculty. And this is in week 6 information videos. So click on that. I actually posted 2 plans today, a week 5 from last week and also week 6, because we didn't really finish any week 5 stuff last week, but we'll try to finish that today and hopefully combine that with week 6 today. Okay, there's also a PowerPoint slide called the hypothesis testing. So this is a good PowerPoint slide because it covers some basics of hypothesis. This covers some basics of hypothesis testing. That's good to know. And also, in order to make hypothesis testing easier, there's a checklist I like to use. So you're welcome to download that as well. So these 4 things: week 5 plan, week 6 plan, hypothesis testing PowerPoint, and the hypothesis test checklist. Okay. You got all downloaded there. Okay, I see. All right. Okay. Okay, so we'll start with the PowerPoint. And this is the first page of the PowerPoint. Okay, so in hypothesis testing, you're basically going to have 2 different things, one called HO and H1. And HO, they're always going to be fighting with each other to see who's going to win. All right, so that's why they're like that. And the HO is called the null hypothesis. And H1 is called the alternate hypothesis. Okay, now in this class, sometimes we'll see H1 as many of the alternate hypothesis. Other times you might see HA. So HA and H1 mean the same thing. Okay, so again, an inference is an educated guess. So we're going to try to make some guesses today, and the guesses will be in the form of a claim. So right now I claim that the population mean age of a UMGC student is 20 years old. Okay, now, do you think that's a good claim or not? Maybe. Okay, well, based on this class, I think it might be, right? Okay, so I think it is. All right, so basically, okay, now we always make a claim about a population, right? So today we'll look at the population mean, and we'll also look at the population percentage, and we'll also look at the population standard deviation, all right? So collectively, those are called population parameters. So we always want to make a guess about the population parameter, okay? Okay, and mu is like in the center, and so we guess that the center, mean is the measure of center, so we guess that the mu is equal to 20, which is in the middle. And to see if that guess is really true, we're going to take a sample, maybe out of this room or the space or whatever, and average up the ages. And let's say the average age is 19.7. And so we have this sample mean 19.7, and we want to compare it with the population mean. All right. Now, if the sample mean is 19.7, do you think it still might be true that the population mean is 20? Yeah, it might be true, right? Because 19.7 is pretty close to 20. So even though it's not exactly 20, there's still a chance that this mu equals 20 is true. Okay. Okay, now let's suppose we get another sample and we get a sample mean of 19. Do you think mu equals 20 is still true? No, yes, maybe, I'm not sure. Okay. But now what if I get 22? Well, it might be pushing it, right? So there's a certain point where I get away from mu, and that will pretty much suggest that this mu is false. Okay. So if all my guesses are around mu, then there's still a chance that mu is true. But if I get to a point where it's too far away, then it might be false. Okay. So that's like, let's say, Joel, where are you from again? Huh?
Boston.
Boston. Oh, so we have a WCVB TV out there, channel 4, right? Okay, channel 4. All right. And if you get away from, if you're pretty close to Boston, you can catch channel 4, right? But there's a point where you travel far away from Boston, and you won't catch channel 4 anymore. Okay, so that mu is like the channel there. Okay. Okay, but now good question is, when do we know how far is far enough? Okay, like how far do we have to go away from the mu in order to say that mu is not true? Okay, well, we have some terminology for that. If you're in the non-critical area, the mu still might be true, but if you get out in the critical area, which is pretty far away, then that guess is pretty false. Okay. Okay, now as a little review, what's the boundary points between the critical area and the non-critical area called? What is it? I'm sorry, what did you say?
The Z-score?
It's a good guess. These are called critical what?
Is it area?
Starts with a P. This is not area, this is a point. Yes, critical point. And there's usually two critical points, a positive and a negative, usually. Okay. And these are also known as critical values. Critical value. Okay, so here's what we've adopted. So the test statistic is some number based on the sample. And if that test statistic is in a non-critical area, then we do not reject the HO. In other words, the HO still may be true. All right. Okay, but if the test is in the critical area, welcome, good morning. Okay, but if the test statistic is in the critical area, we would reject the HO. Okay, so again, that philosophy is like if the sample is so say the population is in the middle, and if we get a sample parameter like a sample mean, and it's far away, too far away, it'll be in the critical area. If it's in the critical area, it's too far away, then we can reject that guess that the population mean is such and such. Okay. All right, and we're doing there, Kiana, we have this PowerPoint called hypothesis testing that's in the yeah, so I'm in the week 6 information videos, and we got the week 5 plan, week 6 plan, hypothesis testing, and hypothesis test checklist is also good to download because that will hopefully facilitate these problems we'll do today. So I will download all that. Okay. Okay, all right. So basically the conclusion of each test is either reject the HO or do not reject the HO. That's it. Okay. Okay, now okay, now we're gonna start creating our own HO and HA statements in just a bit. But to do that, here's a good table to use. So acceptable symbols for HO and acceptable symbols for HA. Okay. Okay, now HO, you can have an equal sign, a less than or equal to, or greater than or equal to. But in this class, ladies and gentlemen, in this class, HO will always be equal in it. Okay, always equal. Okay, no matter what. Okay, so when I first started teaching this stuff, I've seen these symbols equal, less equal to, greater than equal to in the HO. But now we've sort of streamlined the process. So in this class, we can always get by with equal sign and it will still be okay. But the HA will have these symbols in it, not equal to, greater than, or less than. Okay. Okay, and again, this will, I'll make this more clear as we do some example problems. Okay. Any questions so far? Okay. All right. Okay, now in my stat lab, they're going to talk about something called a right tail test, and a left tail test, and a two tail test. All right. So, so if the HA is mu is greater than something, then we use a right tail test. Okay. So greater than faces to, points to the right, right? So you can just remember that. Greater than points to the right, so we use a right tail test. Likewise, the less than symbol points to the left, we use a left tail test. And if you're either greater than or let's see, Wendy, how old are you? And you can tell me, don't ask a lady their age, none of your business, or and you can give me a fake age if you want. Okay, do y'all believe that? Okay. Okay, so if you're not equal to 36, right? So let's say mu is not equal to 36. If you're not equal to 36, then mu must be what? Well, you must be less than 36 or what? Well, we're not equal to. Greater than 36, yes. So if you're not equal to, you must be the less than or greater than. So if you have a not equal to in your HA, then it can be less than or greater than, which we call a two-tail test, both tails. Okay. Okay, all right. So again, there's again two things, HO and HA. And let's think of HO and HA as these two competitors. Okay. Okay, now in a hypothesis test, you might be able to reject the HO. Okay. Yes.
HA.
HA is the alternative to HO. So
the same as H1.
yes, same thing. Yes. Yes, some books will say HA, some books will say H1. So there's no set there's nothing set in stone on that one. All right, good question. Other questions? Okay, now let's suppose in my hand I have a, let's suppose this remote control is an HO. Let's suppose this case right here is HA. Okay, and let's reject HO. That means we're going to throw it away. It's not true. We're going to throw it away. Who wins? Well, must be HA, right? So HA is the conclusion, definitely. And then we can say something like, we have sufficient evidence to conclude the whatever HA says. Okay. Okay, now let's suppose that, okay, now in the conclusion of your test, you will either reject the HO or you don't. Okay, there's only two possibilities. Okay, either you reject something or you don't. So either HO gets rejected or HO does not. Okay, if HO gets rejected, who wins? H1 or HA, yes. Okay, now if HO does not get rejected, who wins? Is it HO or HA? Say again? That will never happen. But good guess. Okay, so all right, so I probably shouldn't use an example, but here's Trump, here's Biden. Nobody gets rejected. Who wins? Nobody. So what's our conclusion? There's no winner, right? Okay, so there's no conclusion, right? There's no winner. So in that case, we would say we have insufficient evidence to conclude whatever. Okay. So the only way to get a conclusion is to reject somebody. Otherwise, nothing's accomplished. Maybe it's true, maybe it's not. Who knows? Okay. So if you want to really get a definite conclusion, what's the best thing to do if you get this insufficient evidence? Perhaps try to get another sample and hope for the best. Okay, that's what we do. All right. Okay, so here's a problem here in the PowerPoint. So we're going to get some practice now on stating the null and alternative hypothesis. Okay, and okay, so here it says the mean entry-level salary of an employee at a company is $58,000, and let's say you believe it's higher. So that's your claim. You claim it's going to be higher. And we're going to state the null and alternative hypothesis. Okay, so the best way to do this is with that checklist. Okay, so here's a good opportunity for me to introduce that checklist. So you can download the checklist there, and the checklist looks like this. Okay, so the first thing we do is state our claim statement. Okay, so we believe that the salary is higher for IT professionals than 58,000. Okay, and it's talking about mean. Okay, so and again, we always make a claim about the population, and it's going to be the population mean, which is which Greek letter? U, yes. Okay. Again, we believe it's higher than 58,000, and so we believe symbolically that mu is greater than 58,000. So that's our claim statement for this exam. Okay, now next we have something called the complement statement. All right. So let me try to explain what that means. All right, so to understand this, sometimes it might be better to make a number line, and then we're going to graph the claim statement. All right. So in general, we have 58,000. And then I want to shade greater than 58,000. So if I want to shade greater than 58,000, which side of 58,000 am I on? The right side, yes. Okay. Now, is 58,000 greater than 58,000? It's not, is it? And so we don't want to include the 58,000 in our shading. And so we want to exclude the 58,000. To do that, we usually put a circle like that. So circle at 58,000 means we do not include the 58,000. Okay. And we shade everything to the right of that. So all this yellow is the claim. Okay, now the complement is everything but the yellow. So what are all the numbers that are not shaded in yellow? And we can use a different color, right? So is 58,000 shaded in yellow? No. So let's shade that. Okay. So that means 58,000 is part of my complement. Okay. So complement is like the opposite, okay? So let me stress now that the complement is the opposite of the claim statement. So in this case, the complement is the opposite of being greater than 58,000. Okay. Okay, enough. So 58,000 is not greater than 58,000, is it? So what else is not greater than 58,000? Everything under, yes, all the left of that. Okay. And so here's the complement right here. Okay, so I'm going to write that here. So mu is less than or equal to 58,000. Okay, so if you're not bigger than 58,000, you must be the same or less than that. Any questions I'll get that? Okay, now our goal is to get the null hypothesis, which is the HO statement. Okay, and again, in this class, HO will always have equal in it. So in this case, it'll be the same mu, the same original number, which is 58,000, and it will always be equal sign. Okay, so HO will always be equal no matter what. Okay, not less than, not greater than, not anything else, but what? Equal. All right. Now, H1 or HA, this is where we have to use a little bit more critical thinking. Everybody ready? It's important. Wish more people were here. This is really important stuff. This sets the stage for the rest of the term. All right. All right, now the H1 is either the claim or the complement. So you want to choose which one it is, okay? So the H1 will either be mu greater than 58,000 or it'll be mu less than or equal to 58,000. We want to choose which one it is, okay? To choose which one it is, this is where this table comes in. This table back in the PowerPoint. So here's the acceptable symbols for HA. Okay, so HA can either have a not equal to, or greater than, or less than in it, okay? So to tell which one it is, we choose from the claim of the complement, okay? So claim has a greater than, right? And the complement has a less than or equal to, okay? So again, that means I'm either going to put less than. It's either going to be less than or I'm sorry, it's either going to be less than or equal to or greater than, okay? Okay, well, in the symbol for HA, I can have a not equal to, right? I can have a greater than, I can have a less than. So can I have a less than or equal to? No, because it's not in the table. So that means it's not going to be less than or equal to, is it? So the only possibility for HA is greater than. So HA will be mu greater than 58,000. Questions? All right, we'll do a lot more examples, okay? Okay, now there's more to this checklist, but we'll fill it in later on as we do some more practice with HO and H1, okay? Okay, you know, number 6 is an interesting one. We'll do number 6. I'll do one more example with y'all, and then I'll put you on the groups, and y'all can figure out some more after that. So we'll do this one. We'll do this one together. Okay, so here we claim that most adults know that a light year is a measure of distance. Did y'all know that? Okay, so that's our claim. All right. Okay, now the last problem had to do with mean, but this one doesn't have mean in it, does it? So we have another thing in here, and it's actually to do with percentage. Okay, so if most people know, then what percentage of people, for example, would know? Any ideas? Like what? If 3% knew, would that mean most people knew? No. About 10%. 40%. More than what?
More than 50%.
More than 50%. Yes. Okay. And percent has to do with P. Okay. So we use P for the population percentage or population proportion. Okay. So just to clarify, either you have a mu, which is mean, or you have a percentage, which is P, or you can also have a standard deviation, which is what Greek letter? Do you remember? Lowercase sigma, yes. Okay. So in your hypothesis testing there, you're either going to have one of those three symbols right there. Okay. But this one's going to be P, right? Okay. N is more than 50%, right? So P will be greater than 50% or 0.5. So that's my claim. And Angel, we're doing some exciting stuff with null and alternative hypothesis. So I'm glad you joined us. Right. Okay, so again, we're trying to find the HO and H1. So that we'll do the complement. Okay, so all right, so what would the complement be in this case? Any ideas?
Less people don't
Yes,
know.
very good, right? So how would I symbolically write that?
Then they're equal to 0.5.
Yes, very good. Awesome. Okay. Yeah, so P greater than 0.5, and then P less than or equal to 0.5. Very good. Okay. All right. Now let's write the HO. Now, what would HO be in this case? Okay, and we'll still have the same P, we'll still have the same 0.5. So what symbol goes in the HO? Equal, yes. So that's a good thing to know. HO will always have equal no matter what. Okay, don't have to think about that one. Okay. But now HA. All right, so again, we see a greater than in the claim. We see a greater than the claim. We see a less than or equal to in the complement. So which one would go in the HA? And again, we can look at the table of acceptable symbols. So here's the table of acceptable symbols for HA. It's either a not equal to or greater than or less than. So what can the HA be in this situation? Greater than, yes. Okay. So is greater than in the table? Yes. Is less than or equal to in the table? No. Okay. So greater than is the only thing that can go in the HA in number 6. Okay, so P must be greater than 0.5. All right, any questions how we got all that? Okay. Okay, okay, don't worry. We'll do some more practice. So once you get this down, the rest of hypothesis testing is pretty straightforward. Okay. All right, so I'll give you some more examples. Okay, we got blood pressure right here, which is rain specialty. And so rain and windy, you can have that one. We can work together as a group there. And again, just figure out the HO and HA. Determine, I'll say HO and HA. I'll write like that. Okay, I'll give another problem.
We're just figuring out the HO.
HO and HA, yes. Okay, landline phones fewer than 10% is the claim. We'll give that to Kiana and Angel. All right, and then we have Tyler and Joelle. I'll make up one for this one. Okay, so we're going to claim that the standard deviation, population standard deviation, right? All about the population is equal to 10. Okay. Okay, so so out of my stat lab, I see a problem like this about population standard deviation equal to 10. So that's why I'm sort of bringing this up. Okay. All right. Yeah, I brought a lot of paper today. Anybody need paper? All good? Okay, it's right up here if y'all need some paper. Any questions? Let me know.
You're doing too much.
Okay, so let's go over these. All right. Okay, so so number 7, the claim says less than 123, right? And so it'll be claim. Okay, now which symbol? Is it P or X or what is it? It's mu, yes. So mean. So it'll tell you what it is, right? If it's mean or percentage or standard deviation. And so mean, it'd be mu. So mu is going to be less than 123. So less than 123. And then how about complement? Yeah, okay. So the thing is, if you're not younger than 123 years old, right, you must be the same or older than 123 years, right? You can think of it as terms of age if you like. Okay. Okay. And then HO, that's a gimme, right? Mu is what? How much? Equal to, yeah, always equal to, no matter what. Okay. And HA, HA, what do we have for that one? Is it less than or greater than equal to? Be less than, yes. Okay. So the thing is, HA never has an equal sign inside it. Okay. It'll either be a less than or greater than or not equal to. Okay. No equal sign inside the HA. Okay. So in this case, mu less than 123. Okay. All right. Okay. Now number 5 is very similar because it deals with fewer than 10%. And so in that case, which symbol? You what? Want to be fewer than if you say it. Well, 0.1, yes. But is it equal 0.1 or less than? Yes. So P, because percentage is only 10%, so that's going to be P, not mu in that one. Okay. So P less than 0.1. And then we can sort of use number 7 as a guide. So complement. P is they have a greater than equal to there. And then HO, P is equal to 0.1. So for all the 4 claim complement HO and HA, the letter and number never changes. It's just the middle symbol, just getting that middle symbol down. Okay. And then HA. So again, same P, same 0.1. So, but the symbol must be what? From number 7 is what? Less than, right? Okay, any questions on those 2? All right. Okay, now let's go with Joel and Tyler's, okay? So we're going to claim that the population standard deviation is equal to 10. So that's going to be which symbol?
Oh, lowercase sigma.
Lowercase sigma, yes. Equal to 10, yes, okay? And then complement. Okay, for the complement, you can ask yourself, let's see, raise your hand if you're 10 years old. Nobody's 10? That means you must be what? You must be how old? Well, greater than 10 or what? We're not equal. Equal. You must be greater than or what? What else? Not equal to, but greater than or less than, yes. Okay. And of course, greater than or less than must be which symbol collectively? Not equal to 10. Okay. So if you're not equal to 10, you're not equal to 10. Makes sense, right? Okay. And then HO. HO always has a what in it? Always has equal, no matter what. And HA, what would be HA in this case? Same as a complement, yes. Okay. Okay, so that's the deal. HO and HA will never be the same, right? Will never be the same. Okay. That's because HA will never have equal in it. Okay. HO has equal, HA will never have equal. It's opposite. So B, sigma not equal to 10. Right? Okay, so any questions on all that? Okay, all right. So let's go over some more terminology and hypothesis testing, and then we'll do some real hypothesis tests. Y'all ready? Are you ready? All right, here we go. Okay, we're going to start doing a hypothesis with population mean one sample. Okay, so we'll do more claims about the mu, the population mean. Okay, now this PowerPoint that I've been using, so I'm using the hypothesis testing PowerPoint that's in the insights discussion. So again, you can download that and follow along. All right, so this talks about economic dynamism, and here I'm claiming that the economic dynamism of middle-income countries is less than the mean for high-income countries. Okay, and we're given that the economic dynamism for high-income countries is 60.29, and so I'm claiming that let's see, I was talking about the mean, right? So this will be a symbol for mu. So mu is going to be less than 60.29. Okay, and here's all the complement HO and HA stuff. Okay. All right. Now, in an earlier edition, HO would have been greater than or equal to, but remember in this class, HO is always going to be what? Equal to, yes. Okay. Okay, once you have all that, then once you have the claim complement HO and HA that we've been practicing on, then you can find out whether we have a left tail test, a right tail test, or a two tail test. Okay. And always depends on the HA. Okay. So the HA has a less than in it. So less than means use a left tail test. Okay. And we happen to be given the population standard deviation, which is 10. And so we apply the normal distribution. Okay. And also, in all these, we're going to test at some percent level. Okay. So in this case, we test at the 5% level. All right. So when it gives you a, so this level is actually called the significance level. Okay. Significance level. Okay. Now, what condition is the base in right now? Is it delta or what is it? Y'all know? Well, what's the lowest possible level? alpha. And so significance level is also known as alpha. What's that? What's that? No good? Well, anyway. Alpha, yeah, okay. So that happens to be the significance level, okay? So the significance level is alpha, okay? And the significance level, okay, let me go back to something in the PowerPoint. It's actually called the critical area, okay? So the significance level is precisely the same as the critical area. So let me just write that down over here so you can see it. All right, so alpha is precisely the critical area, okay? Okay, so in this case, since we're testing the 5% level, alpha is equal to 5% or 0.05. Okay. Okay, now I'm on slide 37 right now, if y'all are following along. Okay, so since we're using a left-tail test, we draw just the left side of the normal distribution curve. Okay, and the critical area is the blue area right there. That's the, remember, the critical area is like the area on the far left end or far right end. Okay. And so, since we're given a significance level of 0.05, this critical area is 0.05. Okay. And based on this, we find what's called the critical point. All right, now maybe you wonder how they get a critical point of negative 1.6445. Okay. Any ideas how we got that based on what we've done in the last few weeks or so? We used a certain website, right? What is it? You probably could, I guess. But we use this online stat book. Remember that? Okay, now this is sort of a long way, so we don't have to like worry about this now, but we'll see. We'll do a shortcut later on. Okay. So a long way is you want to find the critical point, and we're given an area of 0.05. So we need the inverse website. So you get an area of 0.05. And then we want it to be below. So negative 1.6449 is the critical point that we got. Okay, that's how we got that there. Okay. Okay, so negative 1.6445 is what separates the normal situation from the weird situation. Okay. All right, so next thing we'll do is get a test statistic, and here's a long formula for that. Okay, it's based on the central limit theorem and z-score formula. Okay. Okay, and the test statistic is based on the sample. So we get the sample mean put in there. The mu sub x bar, that's the number in the claim statement, which was 60.29. And then sigma, that was 10. And n is 26 because there were 26 numbers in the data. Okay. And we get this test statistic of negative 8.37. And again, this is a very, very long way to do this problem. Okay. Okay. And then we label that test statistic. And you see it's in which area? Is it critical area or non-critical area? Critical area, yes, okay. And if you're critical area, here's what you do. You reject the HO, okay? So if a test statistic is in the critical area, we always reject the HO no matter what. And since HO is rejected, who's the winner? HA is the winner, right? So we can definitely say that mu is less than 60.29. Say again? All right, so I have an area point 05 and have to find this point. So remember the inverse website will allow us to do that. So enter the area point 05 and then look below and it tells us the negative 1.6449 point. All right. Yeah. Okay. Again, this is a long way, so we won't be getting used to this too much today.
What, this?
Yeah, not today. It's too long. We only got this week and next week. That's it.
Okay.
Right. Okay. All right. So that's the basics of the test there. Okay. You okay, Tyler? What's up? Okay, you got a chair. Okay. Okay. Now, in this class, right. It's okay. All right. So, okay. Now, last week we talked about the mean body temperature. What was it? You weren't here.
Oh, yeah.
98.6. And what was the body temperature? What was the standard deviation population body temperature? And nobody knows, right? So it's not really accustomed to know the population standard deviation. So in this class, we're not going to know it. So since we won't know it, we can't draw the normal distribution. So instead, everything is based on the t distribution in this class, okay? And I have a long example of that, but you want to see the long example or you're going to go to the shortcut? Shortcut, okay, we'll do the shortcut. Okay, let me pick a problem or we'll do a shortcut then. Okay, let's go back to the week 5 plan and let me just do one of these problems. Okay, so let's look at the, we'll do number 11. Okay, so we claim that the mean of Disney World wait times is more than 30 minutes. Is that true, do y'all think? It's true? Probably is, right? Okay. Okay, now to do this, they give us some data here that's going to be in the StatCrunch. Okay, so let's go to StatCrunch and look up the Disney World wait times. And to get to the data site, when you get to this window right here, choose data sets from your textbook. Okay, so data sets from your textbook, right? We're there yet. Oh, you got there. We're doing how we want the stack function. Tuesday is session. Okay, so we'll go to data sets from your textbook. And let's see, we're interested in which one? Let's see, we're interested in data set 33 Disney World wait times. Okay, so we'll click on this drop down arrow and we'll look for 33. Okay, here it is, 33 Disney World wait times. That should give us a bunch of data here to deal with. And it says use the first 40 times, all right? And we want the Tower of Terror ride at 5 p.m., all right? Okay, but we'll use all the times, okay? We're gonna use all the times, okay? Okay, so before we deal with the data, again, we'll access the hypothesis test checklist. Okay, we have the hypothesis test checklist. You ready, Angel? Hypothesis test checklist. Just help us, okay? So now we're gonna write down the claim statement, okay? So, okay, so what are we claiming here? Say again? And not just the wait time, but the mean of all wait times, right? So symbolically, how can we write that? Anybody? Say again? Mu? More than 30 minutes. So more than is which symbol? Greater than, yes. And then greater than 30, yes. Okay. Okay, now the complement statement will be which thing? Yes, okay, so we don't, so again, complement is exactly the opposite. So if you don't wait more than 30 minutes, how much are you waiting? You're waiting 30 minutes or less, okay? So mu less than or equal to 30. Okay, then besides rain, what's the HO statement? Equal, yes. And what else do we have? Mu 30, yes. Okay. All right, how about the H1 statement? Well, let's see. So again, the H1 can only be the claim of the complement. So let's see, the claim has a greater than, and the complement has a less than or equal to. So we have to choose from either the greater than or less than or equal to. So which one can be it? Greater than, yes. Because if I looked at the table, look at the table again. Let's go back and look at the table. Table is very important. Okay, here's the table right here. Acceptable symbols are not equal to, greater than, or less than. Just one of those three symbols. Okay. Okay, so we cannot have a less or equal to, so we must have a greater than. So mu greater than 30. Okay. All right. All right. Any questions on that part of it? Now, in this checklist, we have something called a p-value. Okay, I need to explain what this is. So just hold on. Okay, I have a slide for this. All right, so the p-value, according to slide 53, the p-value is the probability of getting the observed results, assuming HO is true. Okay, so we're going to assume HO is true. And what is the probability to get something assuming HO is true? Okay, well, if the probability is very low, then that will tell me that HO is probably not going to be true. Okay. So what that means is if the probability is very low, if the p-value is very low, then I can reject HO. Okay. And here's what that looks like symbolically. Okay. So if I have a left tail test, then the p-value is the area to the left of the test statistic. Okay. And okay, now this purple area is the p-value, and this is part of the critical area. Okay, so I'll put in also the critical area so we can see this. Okay, so this is the alpha here. The red is the alpha, and if the purple is less than the red, the purple is really to the far left, away from the middle. Okay, and think of the middle as like being the HO. Okay, so if so in that case, the purple will be really far away from the HO, which means the HO was more likely not true, and I can reject it. Okay. So again, if the purple is less than the alpha, then I can reject the HO because the purple has no threat on the HO. Okay. But if the purple is more than the red, then it will encroach on HO, and in that case, HO has a chance to be true. Okay. So again, to reject HO, I need the purple, which is the p-value, to be less than the red, the alpha. Okay, now how to find that p-value? Well, here's where StatCrunch comes in. Okay, everybody ready? Okay, so we'll go to StatCrunch, and we'll do all of the hate this. I have to. Okay, all right, so here's how we're gonna do this, okay? So everybody ready? Lost anybody yet? All right, okay, so to do a hypothesis test, okay, now everything is based on the t-distribution, and so when you see mean, choose stat and then t-stats, okay? Choose stat and then t-stats. And then we're doing one sample. And then we're doing, we have the data with us, so we'll choose with data. Okay, so stat, t-stats, one sample, then with data. Okay. Say again?
Maybe silent.
All right.
So that, and then which one?
T-stats. And then one sample, because we just have the one sample of data of times, waiting times. And then we'll choose with data, because we have the data there. Okay. All right. Everybody there? All right. Okay, now which one are we doing? I think we're doing Spacebound at 5 p.m. Is that right? Tower of Terror. Okay, Tower of Tower. Tower of Terror. 5 p.m. Okay, so we'll choose that here. Tower of Terror, 5 p.m. is right here. okay, 5 p.m. And then we perform hypothesis tests for mu, that's what we're doing. And it wants only the HO and the HA, okay? So HO, it was mu equals, okay? Okay, now StatCrunch will set you straight on what the symbols are. So equal already in there for HO. Don't have to think about it, okay? Just have to put the right number in there. So what number do we put in? Is it 30? Yes, put 30. And it automatically fills in the HA field as 30. But now we have to tell HA which symbol it is. And again, StatCrunch will tell us what the acceptable symbols for HA is. No need to have the table for StatCrunch. The StatCrunch will tell us, do you want a not equal to, or do you want a less than, or do you want a greater than? And which one is going to be? Greater than, yes. So we choose that. And then we click. There's more stuff we can do. We can store a data table. We can show critical value. And significance level. What's the significance level? And it should always be given. Looks like it doesn't give us that. If there's no significance level given, automatically assume it's 5% or 0.05. All right. Okay, so leave it as 0.05 there and then click compute. And it'll tell us a bunch of nice stuff, including the p-value, okay? Now, StatCrunch will tell us the test statistic. Sometimes StatCrunch will ask, or sometimes MyStatLab will ask you for the test statistic. In this case, the test statistic is 2.071931. You can tell StatLab that and it'll be happy if it asks for it, okay? Okay, and but all we need is the p-value, which is right here. P-value is 0.02177829. So we'll just copy and paste that in. Mostly, MyStatLab will ask you for the p-value. So there it is. Okay, so this is sort of like the probability that we get the results if HO is true. Okay, in other words, just saying that we have about a 0.021 chance that HO may be true. So what should we do? Well, this next thing on the checklist will tell us, okay? So if P in this case means p-value. If the p-value is less than the alpha, so let's compare that. So p-value is 0.021778209, and it's less than alpha. Alpha is the significance level, which we assume to be 0.05. Okay, so is it less than? It is, right? So we reject the HO. We reject the HO. You ever rejected HOs before?
Oh my God.
No? Okay, now everybody's laughing, so everybody be quiet. Okay, now if the P was greater than alpha, you would not reject the HO. In this case, we do. So if HO is rejected, then we can say we have sufficient evidence to support H1. So we can say we have sufficient evidence to support, we're supporting H1, right? And let's recall what H1 was. H1 was mu greater than 30. So we have sufficient evidence to support that the mean waiting time is more than 30 minutes based on that data. Pretty safe to say. Okay, now as a little side note, there is a relationship between confidence level and significance level. As we know, so in this case, we have a 5% significance level. So what would the confidence level be in this case? Yeah, it is 95%, very good. Okay, so the confidence level and the significance level are like opposites. Okay, so we're dealing with so significance level means, and I'll write this down too, significance level. Well, I'll say confidence level is 95%, which means we were sort of assuming that things are normal 95% of the time. And the significance level, that's like the 5% in this case. So here we're saying that things are not normal 5% of the time. So that's usually the norm in the world. All right, so that's it. Any questions on that whole hypothesis test? Okay, I'll give y'all one to work on. Let me try to make another exciting one for y'all. Okay, so this time I'll make it easier on y'all, and you don't have to use these. You don't have to use data that's in the StatCrunch. Okay, so instead, let's do number 14, where we actually give you the mean and the standard deviation directly. Okay, so I'll push on the groups again for this one. So Rain and Wendy, and we can have a Kiana and Angel and you and Top. Okay. Okay, so let's first of all go through the checklist. Okay, so everybody fill in just the 1 through 4, and then once you fill it in, once everybody fills in 1 through 4, then we'll proceed from there. And here's the problem again. We were claiming that the sample is from a population with a mean greater than 60. So do the claim, complement, HO, and HA. Okay, now whenever you let's see. Let's see. So Joel and Tyler, if you have the claim, I know what it is. And so if you have the actually we just need HO and HA, right? Really? So okay, so Tyler and the Joel and Angel, if you have the HO, let me know what it is. And everybody else, if you have the HO, let me know what it is. All right, what's the HO? Very good, equals 60, right? All right, about HA, you might have that one. Very good, greater than 60, yes. All right. Okay, so if you can do all that without the claim complement, that's fine. So is everybody okay how we got HO and HA in this one? Okay. Okay, now once you get that, the rest of this is StatCrunch. Okay. Okay, so let's all go to the StatCrunch and put in these numbers, and I'll try to help you along with that. Oh, no. They give us the mean of the starvation, so we can just call that. So, which one? 7. It's always gonna be T-stats. Yeah, because we'll never have the population starvation. One sample, then, no, this time let's go with summer. So instead of with data, we're gonna choose with summer. You can put like the mean starvation of the samples. That's just having trouble logging in. Okay, now there's another thing besides that one. Should we use it instead? Or would you rather just go on? Oh, okay.
Thank you.
Have you found data? No, you see zero. That's a good thing. So stat. And then go to T-stats. So if we're doing a claim about a mean, so always choose T-stats. And then we'll do one sample. And if we have the data, we would choose with data. But here we're given the mean of starvation of the sample, so we can just choose with summer. And then put in the information. Oh, sample size is we're given 300 diastolic blood pressure levels, so sample size is 300. Okay, now right now just try to get the p-value. Sample size was 300 levels, so put 300 levels. No, well, that's the mean. So the mean is 7.75333. Sample size. Now get the HO and HO. What's that? Now we're gonna put in the HO and HO. Now the HO. HO we just got, it was right down here. It's HO and HO. All right, so let's confirm all this. All right, it kicked me out of Stat Crunch, so sorry about this. Say again? Right. Okay, so we have a stat and then t-stats, one sample. This time we'll choose with summary instead of data because we're given the mean of standard deviation, so we just put it in. So what's our mean again? How much again?
70.7533.
Okay, and then sample standard deviation was? That was 11.61618. And then sample size, there were 300 temperatures, so 300. Oh, let me start over again. Okay, so stat, then t-stats, do one sample with summary, right? All this information again. So 70.75333. And what's standard deviation again? Six one six one eight. And sample size 300. And then compute. Actually, no, we need the hypothesis test. So mu is equal to 60, right? And then HA, mu greater than 60. And then we can check the store and data table, check show critical values. And what's our significance level in this case? Yes, 0.01, yes. So this time we want to be abnormal just 1% of the time. So everybody choose 0.01. And click compute. And our p-value is indeed 0, okay? All right, so we'll put 0. All right, so recapping, we have a p-value of 0, and our alpha is which number again? The alpha? 0.01, yes, okay. Okay, so what should we do? Should we reject or not reject? Reject, yes. Because 0 is less than 0.01. So reject the HF. All right, okay, so then we can write the conclusion, okay? So we have sufficient evidence to conclude the H1, right? But H1, so in this case, the population mean is greater than 60. Okay, that's all we gotta do for that. All right, so any questions on the population mean? Okay, now I'm gonna make a claim here about a percentage, okay? So I'm gonna claim that 80% of the world prefers cars over trucks, or prefers driving a car over driving a truck. That's my gut feeling. Okay, now we're gonna test to see if that's true in this class. Okay, so Joel, what do you prefer, car or truck? Car. Okay, so we'll keep a tally here. Okay, so car, car is one. Okay, let you Tyler. Car. Okay, what do you, Angel? Car.
Me?
Yeah.
Car.
Now, just because I claim that doesn't mean you have to choose car now, right? Do you really prefer car over truck?
I don't like big car.
Yeah, me too. I don't. All right. How about you, Rain? Right,
What about you?
car. So that's 6-1. Okay. So you think this claim is true?
Yeah.
Probably is, right? And again, every claim has to do with the population. So I'm trying to make a guess about the entire population, whatever it is. Could be Japan. Okay. So we're using the sample of this room to make us guess about the Japan. Okay. So is this true? Well, we'll find out after the 10-minute break. So right now it's 7:31. Come back at 7:41 and we'll get the answer to this. Okay, so we're gonna go back to the car over a truck, okay? So I claim that 80% prefer driving a car over driving a truck. And out of this class, 6 prefer a car, 1 prefer a truck, okay? So let's do the hypothesis test checklist for this. Okay, so everybody try to fill in the claim, complement, HO, and HA for this claim right here, okay? And I'll walk around and help you with that. The claim. Percent, right? So is it less than 8%, or is it more than 8%, or is it equal to 8%? Are we trying to claim less than 80% or more than 80% or equal to 80%? Equal, yes. So yeah, I want to with that symbol. Equals the decimal. So P equals 1/8. Yeah. Now we claimed that 80% of the world prefer driving a car over driving a truck. Now we want to write that symbolically between this. And right away to the complement each of each. I'm claiming 80%, right? But I'm claiming 79%. But I'm claiming 81%. I'm claiming what? 80%. What should you claim? What?
Yeah, you say 5, that's good. Better one.
Yeah, I'll do one. Takes me a while. Yeah.
Cute. I got it. Same, but I'm not. Is it same, but I'm not. You don't look cool. You're sweet.
Yeah.
You try. How do you try? What do you do? To stay young?
Don't have children.
You don't have children? Yeah, but you have students, is that the thing?
They don't see me.
Uh,
No, actually, no children. My wife was one. Now, so P equals 0.8. Right. So the complement is exactly the opposite of that. So ask yourself, what if I don't have the claim statement? In other words, in this case, what if I do not have P equals 0.8? What do I have? Then P must be what? Huh? It can't be. We just know it's not 0.8.
Right. Also, it's so it's less than, I think,
It could be.
or equal to,
Well, it can't be. Complement is the opposite of claim.
right.
So claim, we're claiming is pointing.
Mhm.
So two is the opposite of that.
Right.
So what numbers are not pointing? So that would be P.
Yeah.
What symbol can we put for that?
Oh, P is greater than, right, 0.2.
It could be greater. I mean, it could be, if you're not equal to 0.8, it could be, could you be greater than 0.8?
Oh, is it like not like the equal sign with the slash, right? Okay.
Okay, all right. Okay, we got it, so let's fill it in. And then we'll proceed the rest of this problem, okay? All right. Okay, so claim, P is what? P is equal to 0.8, and column is P is what? Not equal to 0.8, and HO is P is what? Equal to 0.8, and then HA is what? Not equal to, yes. Okay, now let's do the rest of this on StatCrunch, okay? Are we ready? Okay, here's how we do it on StatCrunch. Okay, we'll go to stat. Okay, now we're doing about a percentage, right? So choose proportion stats. And then the sample is just this one sample of each of you in this classroom, right? So choose one sample. And then we don't have the data, so just choose with summary. Okay. So stat, proportion stats, one sample with summary. All right, there we got. Then press enter. Okay, number of successes. So that's my X. So let's see what that is. X is X is going to be so the claim is about driving a car, and so in this case 6 out of 7 people prefer driving a car. Okay, so that means X equals 6, and N is the total of everybody, and so N is equal to what? 7. So X is 6 and is 7. Okay, so the successes is the X. 6 here. And then number of observations, that's the N. So put 7, 6, and 7. Okay. Okay, then perform hypothesis test for P. That's what we're doing. So P is equal to, again, equals already always there. 0.8, very good. And then fills it in the HA. And HA, we want which symbol? Oh, which one? Not equal to, yes. All right. And then we can click on store and data table, show critical value. Okay, any questions how we got that? Everybody with me? Okay, then compute. Okay, and again, all we need is that pivotal p-value. Okay, which is wow. Never expected that.
Question. How's your 0.95?
Sorry?
0.95. If you go back to options.
Okay, now we're not choosing the confidence interval. So you either choose hypothesis test or the confidence interval. So confidence interval is stuff we did last time, so you choose that for that. But here we're choosing just this. Yeah. All right, compute. All right, here's the p-value again, which is mind-blowing. And why is it mind-blowing? It's mind-blowing because do we reject HO or not reject HO? Well, let's see. So p-value is 0.705 for 5699. Okay, now that's saying that there's a 0.7054 chance that the HO may still be true. So in that case, should we reject it? No, because that's a high chance. So, and this confirms the force. We have p-value p. We have alpha, which is, what's alpha in this case? .05, right? Because we didn't really specify. So just assume it's 0.05. Yeah, 0.05. And is it, do we have less than or greater than? Greater than. So this is greater than, then do not reject HO. So then that tells us what to do. HO is not rejected, so that means we have insufficient evidence to support anything. Okay, so we have insufficient evidence. To support that exactly 80%. So that's the problem. We're saying exactly 80%. Prefer driving a car over a truck. Okay, so any questions on this kind of test? Should we do another one or move on to a different population parameter? In other words, should we do another percentage test or move on to another kind of test that's not a percentage? What do you like, Joel? Move on to another one or another example like this? Okay, another one? Okay. Are we ready for another one? Okay, so instead of another percentage test, we'll do a standard deviation test. Okay, now we did the standard deviation of the roles last week. And then what distribution of data did it have? So remember that we rolled a die last week. We found a standard deviation of the numbers in your roles. And what was the data distribution of the standard deviations? It was normal, right? But if you do it for many people around the world, then it should be what kind of distribution? Is this a certain Greek letter? It looks kind of like an X. So last week we said that if you take a bunch of standard deviations and find the distribution of data, then it should look like this kind of distribution. And it was the chi-square distribution. Chi. Chi is the Greek letter for X. And it's skewed to the right, yes. Okay, because most of the standard deviations should be lower numbers. All right. Okay, so there's a long way involving the chi-square distribution that I can show. So you want to see the long way or just from here, just go to the shortcut. What should we do? Long way or shortcut?
Long way.
Long way. It's nasty. Don't ever do the long way.
You said shortcut last time, you showed us the long way.
Well, so we have these weights of coins. And this is on slide 75. So summarizing what we have here, when it tests a claim that the sample is from a population with standard deviation less than 0.04 grams. So we're doing a test about standard deviation. And here's the And here's all the here's the weights of 16 quarters that we got. Okay, all right. Now, if you do a test with a standard deviation, my stat will confirm this for you, that the population must come from a normal distribution. Okay, so any test for standard deviation, the population must come from a what? A normal distribution. It's pretty strict. Okay, so make sure that it's based on the normal distribution. And I think we have it here because if you have weights of quarters, they should form a normal distribution. Okay, some weights are less than usual, some weights are more than usual, but most of the weights should be around the average, which is normal. Okay, so we do have that. And so here's the usual claim complement HOHA. And then you want to find the critical point, which we get by using a chi-square table. And this is the chi-square distribution right here. And then you find a test statistic with this formula right here. And you get 4.4394. You label that on a picture, and that's going to be in the you think that's the critical or the non-critical area? Or the 4.43904 is? Critical, probably, right? And it is, okay? So, yeah, so that's what we get there. Okay, ready to see the shortcut? Let's do a shortcut. We're gonna do birth weights. Okay, so I'll give you a few seconds to read that very exciting problem, and then we'll work it out. Okay, now we look at that. Do you think this claim is true or false? In other words, we're claiming that the birth weights of girls have the same standard deviation as birth weights of boys. Is that true or false still? Huh? Well, I mean, we're claiming that for boys it's 660.2 grams, right? But you get a set of data with girls, what's its standard deviation? 829.5, right? So, same. It's like we're comparing 829.5 with 60.2. Are they the same? Probably not, right? So, this claim might be false. So let's find out. Little checklist. Okay, so same thing. See if you can fill in the claim, complement, HO, and HA part of this thing. Okay, so I'll try to get it closer as you can see it all. Okay, so see if you can fill in the claim, complement, HO, and HA. 19.5, we have 66.2, so which number replaces it? Which percentage? Here, now this 19.5 is a sample, but the claim is always about a population.
Oh.
I don't know.
Let's see the sigma, and see the 66.2. What symbols and equals? Equal.
Are you reading something?
Okay.
Are you reading something?
Let's see, we're claiming that the birth weights of girls have the same generation as the birth weights of boys. So in other words, we're claiming that the birth weights of girls have the same. We're saying that it's the same at 660.2.
Yeah.
So same means equals.
And then the symbol is sigma for the standard deviation.
Yes, very good. Sigma. From Louisiana, why they say Sigma in Louisiana? Sigma. Sigma. I don't know what the other- Not everyone is having somewhat right.
Yeah.
Or you can just put the. Usually insert. Insert the top there.
Yeah, so I see it's a symbol.
Yeah. Okay. So what's our claim? Sigma then equal 660.2, yes. Okay. Okay, now it can be confusing which number goes in there. But remember, the claim is always a number associated with the population. So here it says we have a simple random sample of birth weights of 30 girls have a standard deviation of 829.5 grams. And so this standard deviation of 829.5, this is the standard deviation of the sample, right? But we don't want the sample standard deviation of the claim. We want the population standard deviation. So it must be the number must be the other number, which is 660.2. That's why it goes there. Okay. And then once we have that, we can pretty much get the rest. So the complement is sigma equal what? Not equal to, yes. Either you are 660.2 years old or you're not. And then HO must be equal. And then H1 must be not equal to, yes. All right. And now after that, we're ready for that coveted p-value again. Any questions so far? Okay, so again, StatCrunch will help us for this one. Okay, this time go to stat. And then we normally would choose the standard deviation stats, but let's choose variance stats, okay? So if we're doing a standard deviation or variance, just choose variance stats, okay? And then one sample, and then let's see, should we choose with data or with summary? Okay, well, the data is actually there, but we have a summary here, so that's good enough, okay? So we'll choose with summary. So variance stats, one sample with summary. We'll put in the sample variance. Now, what's the sample variance? Do you know? Well, let's say the sample standard deviation is 829.5, but we need the variance. How can we get that? Square it, yes. Now, do you know what the best thing about StatCrunch is? We don't have to square it because we can enter it in like this. We can say 829.5, and then we're gonna type the caret. You know where the caret is? It's a shift 6. Shift 6. And then type 2 because it means raised to the 2. So 829.5 caret 2. Or you could square it manually if you wanted to, but I don't think you want to do that with this big number. Okay, so there we got it, 829.5 caret 2. Okay, Angel, yeah. No. All right. Okay, and then sample size is what? 30, yes, because we have a sample of 30 girls. Okay, sample of 30 beautiful girls. All right. And then we choose hypothesis test for sigma squared because it's variance. And then just put the information. Sigma squared is equal to what? 660.2, but we also have to square it. So we'll type 660.2 caret 2, like that. And then HA is what? Not equal to, so it's already chosen for us there. And then do all this stuff, store in data table, show critical value. And make sure to enter in the right significance level after that. Let's make sure of that. It's a 0.01. So I change it to 0.01. Okay, any questions? Everybody there? All right, and we'll choose compute. And again, all we need is the p-value. So p-value is right here, 0.0493, etc. Okay, and if it asks you for the test statistic, I think it says right here, it's the chi-square stat would be the test statistic in this case. Okay. All right, so enter the p-value. And after that, same general thing as before. Should we reject or not reject? What should we do? Yeah, write down the p-value again, 0.04934278.4. And the alpha, what was alpha again? 0.01. So reject or no, or not reject. Not reject, yeah. Because it's greater than, right? It's greater than, so don't reject the hoe in this case. Okay, now here's like for all to do. Okay, so based on that, write a concluding statement. Like you can say something like we have sufficient evidence to conclude this, or we have insufficient evidence to conclude this, or something like that. So write something like that, and I'll come around and try to help you with that. Okay, so is it sufficient or insufficient? Okay, so here's a good thing to keep in mind. If you don't reject, if you not reject, not sufficient. If you do reject, you do have sufficient, right? So reject and sufficient, same thing. Okay, so just remember, not sufficient, not reject. All right, now, have you ever been in you across the runway a lot? Okay, when you cross the runway, what do you not do for pedestrians? Don't stop, right? So on the runway, it says stopping no. You ever notice that? Doesn't say don't stop, it just says stopping no. You don't say no stopping, it says stopping no, stopping no. So reject no, sufficient no. You got that? All right, good. So yes, we have insufficient evidence. Standard deviation of boys' weights, birth weights, is the same as girls' weights. Okay, kind of makes sense, right? Because we have a 829.5, 660.2. So they're probably not the same because two numbers very spread out. Okay. All right, so any questions on the standard deviation part? Should we do another example like this, or is that good enough? Are we good? Okay, so raise your hand if you want to do another example with standard deviation. Okay, we'll move on. Okay, this next thing we'll do is a question I see a lot in my stat lab, so this will be really worth looking at. Okay, this is right out of my stat lab. Okay, you get a test statistic of z equals 1.87, and the claim is p greater than 0.8. So identify the hypothesis as being two-tailed, left tail, or right tail. Okay, so now it's based on the HA, right? So what's the HA in this case? Try to make it bigger. Yes, very good. So if you go through all the claim column HA and HO, you'll discover that HA is P is greater than 0.8. Okay. Okay, so is this left tail, right tail, or two tail? Right tail, because greater than, right? So greater than points to the right, so it's right tail. And of course, it says right there. Gave you the answer already. Isn't that nice of me? I gave you all the answers. Okay, but I didn't give you the p-value answer. Okay, the question is, how do I get it? Okay, well, unfortunately, StatCrunch or even StatDisk cannot help you get the p-value for this. Okay, so what can I do? Well, here's what we do. I got this out of one of the PowerPoints. Somewhere. Oh, here it is. Okay. So one of the PowerPoints has this flow chart in it. Well, can't win for losing here. Okay, so this flowchart will tell you how to find the p-value. Okay, so we'll start, and then what type of test do we have? Is it left or right? It's right. So we'll go down here, and it says here that the p-value is area to the right of the test statistic. Okay, and it says it's right tail. We're just going to draw the right half of this thing. And the test statistic is given to be 1.87. And it says Z equal that, right? So what does Z stand for? Do y'all know? It's this kind of score. Z score, yes. And that's and Z is indicative of a normal distribution. So basically we're given a normal distribution and we want to find the area to the right of the 1.87, and that'll be the p-value. Okay. And how do we find that? Using what we did previously in previous weeks?
Yes. Or is it no, it's the normal one.
The normal one, yeah. So every go to normal and see what go to the online stat book, not the inverse, but normal. And website. I think so. Yeah, that one. Yes, yes. And put in or no, that one. And scroll down. Then we put in find error to the right 1.7. So right is so if you're to the right of 1.7, are you above or below? Yeah. If you're to the right, you get higher numbers or lower numbers. Higher, which means we'll be above. Yeah. Put in 1.7. And then click recalculate. Tell us the error. See that? That's the p-value that we're looking for. Right. So here. Get it? When you get to know 0.3007. That's it. So that's the p-value that they're looking for. Right. So the area is 0.0307, is that right? Okay, all right, so that's our p-value there, and put it into stat this there, and it'll be happy. And it says round 3 decimal places, so 3 decimal places, that'll be what? How much?
0.030. 1.
1, yes. Yeah, 0.031, yes. Okay. Okay, all right, so that's it for that. Okay, we'll do another example like that. You ready for another example? And again, it's based on that flow chart. It's a flow chart on slide 53. Okay, very helpful flow chart. Okay. And by the way, the C part is just we need to do the C part. C part is just asking us should we reject or fail to reject, and you use what we did before already. Okay, so let's just do A part and B part for this next one. Okay, this one's good. Okay, we'll just do this part. Okay, so we claim that mu is less than 3, given a test statistic of z equals negative 1.41. Find the p-value. All right, so see what you can get with this one. Right tone, two-tone test. Left, yes. So what we really want is the flow chart. Test, actually that this one want the there to left of the yeah, below the negative 1.4.
I just assumed.
All right, so what's the answer in this case?
0.079.
Okay, 0.079, is that right? Anybody see how we got that? You want to see? Okay. Anybody want to see? All right. Okay, now this one's a little bit more challenging, but the flow chart can guide you in the right direction. We'll do the same thing. But this time, what if mu is not equal to 3? It would be okay. Now this one's probably misleading here. So let's go to the flow chart there. And if you go to the flow chart, there's a branch for left tail and a right tail, but no two tail is there. So two tail is this way. So you go down. And then it asks, is the test statistic to the left or to the right of the center? So is it to the left or to the right? And we have negative 1.41, so is that on the left or on the right? Left of the center, yes. So negative means left, positive means right. So we'll go to the left down that branch, and it says p-value is twice the area to the left of the test statistic. So in that case, what would it be? It is.
1586.
How'd you get that?
0.07.
Second.
Multiply
Okay, multiply this by 2, yes. So since we're doing twice the area, we have to do 2 times 0.079 or whatever it was, I guess. That should give us 0.1586. Okay. A little tricky there, right? Okay, any questions on that? Okay. Okay, so all that has to do with one sample. Now, what if you have 2 samples? We're gonna do testing with 2 samples now. Right? Okay. All right. Okay. Now we want to compare 2 samples here. Okay. So you can have the sample of people who just started violin, like this person. Okay. And then you have these maybe people who might sound like this. Wow. Okay.
Can I?
Yeah.
You know, play? Yeah. This one, huh?
Been years? How long?
Yeah, since I've moved here.
Oh, okay, all right, so we want to compare like sample with the beginners and people like that. Okay, all right, and more specifically, we can do it before and after tests. Okay, so maybe you're a violin teacher. Maybe the first day you want to see how your student sounds, and maybe you know, you hear how they sound, and then you use that to figure out a lesson plan for that student. And then maybe after 3 months of lessons, then you compare them after the 3 months and see how they sound. So, okay, so that's an example of when you want to do when you want to compare before test with the after test. Okay, all right, so okay, now again, we can do the long way or the short way. Which do you want to see? Short way, okay. All right, so long way is all in the PowerPoint. It's pretty long. Okay. I don't recommend a long way. It's all there. All right, we'll do a shortcut. Okay, now this will be in the week 6 plan. So I also posted the week 6 plan. Anybody else play violin? No. You do?
No.
Oh, all right. Okay. Okay, all right, so uh, okay, now I'll give you all a test, okay? So which font do you like better there, Joel? Do you like the top one or the bottom one? Which is more appealing to you? The top, okay? All right. How about you there, Tyler?
Top.
How about you? Okay, no, just because they chose top, don't have to choose top, no. But you like bottom, okay, how about you? How about you? Okay, 2 for bottom. And 4 for top, okay, all right. Okay, now the top one, say again? Okay, the top. Okay, now, does anyone know what font the top one is? Times Roman, yes, that's the most popular one. How about the bottom one? Arial, I believe so, yes. Okay, so there's a nice test we can do here, okay? We'll do this one here. Okay, so we want to test a claim that there's no significant difference in readability between Roman and Arial. Okay, so do you think there's no significant difference in this classroom? Or each of you had a preference, right? So maybe there's a difference. Okay, let's test the claim that there's no difference. Okay, and to do this, we have to have some kind of a readability score. All right, and we combine reading speed and accuracy into a readability performance score. Higher score represents better font readability. Okay. Okay, so we're going to use a 0.05 significance level to test the claim that there's no significant difference in readability between Roman and Arial fonts. All right. Okay, and here's these stats right here. So n equals 24 means we surveyed 24 people, and the average for Roman got 66.25. And standard deviation 12.96, and Arial 24 people, 24 different people. Okay, so we had 24 people read the Roman, and that's their stats there. And we had another 24 people read the Arial, and this is the mean and the standard deviation for that. Okay, so the means look pretty close. So does it mean there may be a difference or no difference? Probably no difference, right? Okay, so font doesn't really make a difference on how well we can read it. Okay, but let's do this formal test. Okay, do a formal test. Since we have two different samples here, which are the Roman sample and the Arial sample, we're going to keep it straight by identifying which one's group 1, which one's group 2. You don't have to do this in StatCrunch because it'll lay it out for you. But still, it's good to know which is group 1, which is group 2. Okay. And we're going to use the same kind of hypothesis test checklist as before. Okay, so we're claiming that there's no difference, right? So, and since we have two samples, we're going to have and we're doing a mean, right? We're doing the mean. Yeah, we're doing the mean. Doesn't really say, but it'll say on my set, it'll say, okay. So we're going to claim that mu1 So that's the mean for the group one, which was Roman. And we're saying that there's no difference, right? So no difference means which symbol do you think? Equal, yes. No difference means they're the same. So we're saying that mu1 is equal to mu2. So mu1 is the mean for the Times New Roman, and mu2 is the mean for the Arial. Okay. Okay, now the rest of it is pretty straightforward as before. So complement, what do you think that would be? Not equal to, yes. And the rest of it's still the same, mu1 not equal to mu2. Okay, and then HO, mu1 equal mu2. And so HA must be what? Mu1 not equal to mu2. Any questions? All right, okay, now we got to find the p-value again. Okay, all right, and again, StatCrunch will gladly give it to us. Okay, so we'll go to stat. Okay, now we're doing a test for a mean, right? So which do you want to choose again? T-stats, yes, always choose T-stats. And then this time we're given two samples, so choose that. And we don't have the data directly, so we'll choose with summary, okay? And then you gotta put in all this information. Okay, so sample one, that's the Times New Roman. Put the mean, standard deviation, and size in. Let's recall what that was. Okay, maybe I'm gonna put the mean in first, 66.25. And sample duration 12.96. And sample size is 24. Right? And then sample two. That's the Arial. So sample two mean is 65.62. Sample standard deviation is 9.93. And sample size is 24. Right? Okay, I'll let you see that so you can enter it in. All right, 66.25, 12.96, and 24. There we got. Oh, Tyler, you got? I'm sorry. Yeah. 66.25, 12.96, and 24. And 65.62, 9.93, and 24. Second? Oh, you got it all in? Yeah, looking for the p-value again. So everybody got it in? Okay. And then well, we got to put in the hypothesis test. Okay, now this is kind of weird here, but let me try to clear this up. Okay, in StatCrunch, they say mu1 minus mu2 equals 0 for some reason. Let me try to explain what that is. Okay, so traditionally, whenever you do a two sample test, you have to get 0 on one side. Okay, so we have mu1 equal mu2, and we want to try to get 0 on one side. So any ideas what we can do to both sides of the equation to get 0 on one side? See it? Divide by what? Huh? Well, divide's not gonna work. Okay, so let's see, what y'all have for lunch today? Anything for lunch today? Chicken wrap. Okay, what'd you have there, Wendy? Oh, I thought you started to say something.
I just have food from 7-Eleven.
You said food from 7-Eleven. What'd you say?
Food from 7-Eleven.
Oh, food from 7-Eleven. Okay, all right. Just in general food, all the food?
Salad.
Salad, okay. All right. Okay, so what do you have? Chicken. Okay, chicken's good. Okay, so let's suppose mu2 is chicken, right? Now, how do you change chicken to 0? Eat it, right? So, okay, so if you have 3, how do you change 3 to 0? You eat the 3, but mathematically, what do you do? Subtract it, yes. You take it away, right? So we're going to subtract the mu2 from both sides. And then you get mu1 minus mu2, which is still mu1 minus mu2, equal mu2 minus mu2 is what? 0. Okay? So that's what they really want you to put in StatCrunch. Say again?
Since it does it for you automatically, you just leave it. Yes.
What?
Since it does it for you automatically, do you just leave it?
Yeah, leave it like this, yes.
Okay.
But I just wanted to try to explain why it says that.
Okay.
Yeah, okay. All right, so it says that, and then we know it's not equal to for HA, right? Okay, we'll leave that. And then same thing as before. Check, check. And significance was what? Let's see.
I think it was 0.05.
105. Thank you so much. 105. All right, that's all we got to do. So click compute somewhere. There it is. And p-value is right here, very big p-value. So that means more than likely, are we going to reject or not reject? Not reject. Oops. There. All right, so yeah, so you got 0.85 something. And then less than or greater than. Greater than, yes. Much bigger than 1.5. And so we don't reject HO. So it means we have what? Insufficient evidence. So reject no. Sufficient no. N'est-ce pas? So insufficient evidence to conclude there's a difference or no difference between readability. All right. Okay, so should we do another like that or move on to another kind of test? Everybody good? Move on. Okay, move on. No?
Sure.
You got it?
Yeah.
Okay. Okay, we'll do another kind of test. Let's see. capital. Okay, there's more example of mean, but we'll do a, now let's go, okay, I forgot to do that, okay? So there's I forgot to finish that problem that we just did. Let me go back and finish that problem. Okay, that was the A part, okay? Then B part says to construct a confidence interval suitable for testing the claim in the part A, okay? Now my stat lab will do a lot of problems where you have to construct a confidence interval in addition to a hypothesis test, okay? So to construct a confidence interval, we can go back to what we have and then click options and then click edit. Okay, do options and edit. Everybody there? Options, edit. All right, then we're going to scroll down. And this time we'll choose confidence interval for mu1 minus mu2, okay? And then, now the significance level was what? Significance level was 0.05. So what would be the corresponding confidence interval? 0.95, yes, okay. And in order to confirm this, so we can use a little formula for that. All right. So this is A part. Now we're doing B part. Okay, so B part, to find the confidence level, we'll do CL is equal to 1 minus alpha. That's a good thing to know. CL, confidence level, is 1 minus alpha. Okay, so confidence level is equal to 1 minus alpha was 0.05. And so 1 minus 0.05 is what? 0.95. Okay, 0.95. So we'll put in 0.95 into StatCrunch, which is already there, 0.95. Okay. Okay, and then we'll keep everything checked as before, and then click compute. All right, now how do I get a confidence interval out of that? We'll go back and do that again. All right, I didn't choose confidence interval. All right, let me scroll down again. Okay. Okay, this time I have to choose confidence level, confidence interval. Okay, choose that, and then compute. Try this again. And the confidence interval is always the L limit and U limit. Okay. Now, here's what it's saying. It's saying that we have negative 6.09066684 is less than that mu1 minus mu2. Is less than. So L limit means lower limit. That's the lower limit of the confidence interval. And less than mu1 minus mu2. Less than upper limit goes over here. It's a 7.35066684. So that's my confidence interval for this problem. Any questions? Okay, now again, we're trying to test the claim, whether there is whether there's a what? Whether there is a, whether there, we're trying to test the claim that they're the same, okay? There's no difference, they're the same, okay? So if you see they're the same, we have to analyze this confidence interval, okay? All right, now you want to ask yourself, does this confidence interval, so does this confidence interval contain 0 or not? And so what's the answer to that? And why is that, Rain? Okay, and so yes, so 0 is between, what you're saying is 0 is between the negative 6.09 something and 7.35 something, right? So is that true? Is 0 between, so here we have a negative number or a positive number, and is 0 always between the negative and the positive? Yes, it is. So it does contain the 0. And so what this means is, this means that it's possible that this number in the middle here can be 0. So yes, it does contain 0. So since the answer to that question is yes, it does contain 0, then that means this can be 0. Okay, so mu1 minus mu2 can be 0. So what is that saying? Well, so we can say it's possible that mu1 minus mu2 can equal 0. But now let's solve for mu1. Okay, so if you solve for mu1, how can we do that? Any ideas? See?
I don't know if it's 9 o'clock.
Well, let's look at a simpler equation. Okay, so what if you have like x minus 4 equals 10? How'd you get x by itself? Add 4 to both sides. So instead of 4 over here, we have what over here? Mu2 over here, right? So what do? Add mu2 to both sides. And what is that telling us? That's saying that mu1 is what? Equal mu2. So that's saying they're the what? They're the same, right? So this confidence interval actually says that the claim is true. Okay, so we claim that that there is no difference between both fonts. Okay, so sometimes the hypothesis test will say something, and sometimes the confidence interval will say something else. Okay, but mostly they're going to say the same thing. Okay, so I did have planned do two samples for proportion and standard deviation, but it's pretty much like the similar idea. You just go to StatCrunch, and you can choose variance stats 2 sample and do the test for the variance for 2 sample. Okay, there's another thing that's called there's another thing that's specific for 2 sample, like with the before and after that I mentioned before. To do before and after, we'll try to do that next time. That's sort of more specialized, so we'll look at that next time. Okay, so
Is that in the week 6 one?
good question. It's probably week 6, yes. Yeah, week 6. Yeah. But we'll do more of that next time. So next time we'll try to do more with it's called testing with testing of matched pairs. Okay, so if you want to test before and after situation, we'll do tests for matched pairs. We'll try that next time, and then we'll try to do the chi-square test and the NOVA test next time as well. So all that will be next time. So thank you so much.